Hi, CAP&GOWN scholars. It's Mr. Bradford here. And our topic today is ACT Math Exponent Operations. All right, let's get it. All right, so before we get started, I want to remind you of some exponent operation rules. So if we have something like, if we have the same base, with different exponents, all we have to do, and we're multiplying them together, we simply add the exponents, and that'll give us our answer. So let's say we have like x squared times x to the third, then we'll end up with x at the exponents, keep the base at the exponents, and that'll give us 5. Pretty simple rule. All right, similar rule here. If we are dividing and we have the same base, same exponents, so we'll say x to the 5th divided by x to the 2nd, then we'll take the top minus the bottom exponents, and we'll get 5 minus 2 is 3, okay? And then our last rule that we need to review is if we are raising a power to another power, all right? So let's say we have x to the 2nd, and we're raising it to the 3rd power, all right? That means we need to multiply the exponents. So 2 times 3 gives us 6. All right, we need those 3 rules in order to do the ACT problems we're about to do. All right, this question tells us to simplify -7x to the 4th times 4x squared. Now we're going to use those rules that we just used a minute ago. All right, so we'll take -7x to the 4th times 4x squared. We have the same base. All right, so we're in good shape. Let's take -7 times 4. That'll give us a -28. Then we'll multiply the base, or keep the base. We're multiplying, add the exponents. 4 plus 2 is 6. So we'll see your answer choice D has both -28 and x to the 6th. That was pretty easy. Here's a little bit more complex question. Same concept, same process. Let's take a look. So this says, for non-zero values of x and y, which of the following expressions is equivalent to this expression? All right. So we're going to use our division rules here. So I have 24 divided by 4. That should give me 6. And then I have x to the 4th divided by x to the 1st. Well, I'm going to say top minus the bottom. All right. Don't forget there is a 1 there. And then I'm going to do the same here for my y. Y to the 3rd minus y to the 1st. Okay. Simplify that. -6. X to the 4 minus 1 is 3. 3 minus 1 is 2. And let's see if we have an answer choice that looks like that. First one, -6, x to the 3rd times y to the 2nd. All right. Again, not too bad, same concept. Let's look at another. For what real value of a is the equation x squared raised to the third power times x to the fourth raised to the fifth power is equal to x to the a power. So really we're finding the value of a since we see we have the same basis. All right, so I'm going to rewrite it. X cubed times x to the fourth. All right, if I have a power raised to a power, I need to multiply the exponents. So that's x times 2 times 3 gives me 6. And this 4 times 5 gives me 20. So now I have a situation where I'm multiplying, and so I have the same base. I need to add the exponents. Keep the base, add the exponents. That should give me 26. All right, so A in this case is 26. And that answer choice is J. All right, let's take a look at another one. All right, for our next question, we need to review radicals as fractional exponents. Okay, so any radical can be rewritten as an exponent that's a fraction. So the cube root of 8 can be rewritten as 8 to the 1/3 power. Notice that this index is in the denominator. All right. This index is 2. It happens to be in the denominator again. So square root of 15 can be rewritten as 15 to the 1/2 power. So here's the rule. Whatever the index is, that's going to be your denominator right here. Okay, we're going to need that. Another thing you need to remember is if you have two radicals that have the same index, you can take both of those values and place them under the same radical if they have the same index. It's also true if they have the same exponent because these two things are equivalent. All right, so we're going to use part of that in our next question also. So this question says, for all positive values of g and h, which of the following expressions is equivalent to this expression? All right. So we're going to rewrite this. We have h squared. And then we have the fourth root of h to the fifth. The fourth root. All right. So we're going to take the square root of g to the fifth. So since this is a 2, if you remember, we're going to take the g squared here. And we're basically looking to see how many times will g to the fifth, or will this 2 go into g to the fifth? So that should be 2 times. That means I can take 2 of these out. And it leaves 1 inside of here. So again, I have g to the fifth. 5 divided by 2 is 2, and I leave 1. So 5 divided by 2 is 2. I'm leaving 1 in, and I'm going to do the same here. H squared is there, and 4 will go into 5 one time. So that's h to the first power, and I have a remainder of 1h. And again, this is the fourth root. Okay, I'm getting close. So if I multiply these, add the exponents, that's g to the fourth, square root of g times multiply these two together. H squared times h to the first. That should give me h to the third. And then I still have the fourth root of h. Well, nothing over here looks like that quite. I do have g to the fourth and g to the third, so that's a possibility. Let's see if we can make it look exactly like the answer. And that's when we're going to get into our fractional exponents. So I have g to the fourth. This can be rewritten as g to the 1/2 power. And this, I have h cubed. And this can be written as h to the 1/4 power. All right, we'll take the g and the h. We'll move them over here. G to the fourth, h to the third. All right. This part is where it gets funny. So g to the 1/2 times h to the 1/4. Well, if I wanted to get these with the same denominator, then let's take this, make this the same denominator, and we can call it 2/4 instead of 1/2. 2/4 is equivalent to 1/2. So now I have the same denominator. That means I can put them in the same radical. So we'll keep that. G to the fourth, h to the third. Both of them are fourth roots. So this is g. I still have the squared here. All right, and then this is h to the 1/4. So that's just h. And let's see if h is our answer. Yes, it is. So h is our final answer there. That's a little bit longer. That's a question that you might see closer to the end of a test or middle of the test, but you do need to know your exponent rules. All right, last one. Which of the following equations expresses C in terms of A for all real numbers A, B, and C such that A cubed is equal to B and B squared is equal to C? All right, well, I'm going to start here at C. It tells me that C is equal to B squared. All right, well, what is B squared equal to? Or what is B equal to? B is equal to A cubed. So B was replaced with A cubed, and it's still squared. All right, so let's see what C is equal to in terms of A. All right, I have a power raised to another power. That means I need to multiply the exponents. All right, 8 to the 6th, and I see that that answer is F. All right, thanks for tuning in. That's all for today. Keep working hard, and don't forget, where you going? College. All right.